In this video, I will take you through these 6 examples, and along the way, I will remind you of several exponent rules. Let's start off with these 2 examples. The first rule you need to remember is power to a power, multiply. All right, so there as an example, I have 2 to the power of 5. So power to a power multiply, 3 times 5 is 15. The exponent on 4 is 1. So let's apply power to a power, multiply, and I'm going to have 4 to the 2/3 power. The next rule that we need to go over is what I like to refer to as inside over outside, or sometimes just inside out. That's to remind you that the number in the numerator becomes the exponent on the inside, and the number in the denominator becomes the exponent on the outside. Applying that, the 2 in the numerator is going to be the exponent on the inside over outside. So the 3 in the denominator is going to be the number on the outside of that root. The 4 to the 2nd power becomes 16 because 4 times 4 is 16. Let's do a little scratch work with 16 to simplify this root. 16 is 4 times 4. And each of those 4s is 2 times 2. So let's replace the 16 with 2 times 2 times 2 times 2. When I have an index number of 3, I need 3 of a kind to take a number out. So I have 3 2's, so I'm going to be able to take out a single 2, and what's still going to be underneath the root is a 2. So my final answer is going to be 2 cube root of 2. In the second example, we need to begin by using the power rule, power to a power, multiply. The exponents on 1 and 32 are both 1, so let's multiply 1 times 4/5 and 1 times 4/5 again. So I have 1 to the power of 4/5 over 32 to the power of 4/5. Now we're going to use that inside out rule to rewrite those as roots. So the 4 in the numerator, inside, that one's the one that goes on the inside, and the denominator goes on the outside. Again, inside over outside. Simplifying 1 to the 4th power, we get 1. And then in the denominator, I'm expanding 32 to the 4th power. Now, if our index number is 5, that means I need 5 of a kind to take something out. But each one of these 32's is made out of 2 times 2 times 2 times 2 times 2. So for each set of 5 2's, I can take out a single 2. So I take out a 2, another 2, another 2, and another 2. In the numerator, the 5th root of 1 is going to be 1. Keep in mind, 1 you can multiply by itself as many times as you want, and it's still 1. So we have 5 of a kind, 5 1's, and we get 1. Our final answer is 1 over 16. In example 3, the main difference is the negative exponent. One strategy to get rid of that negative exponent is to take the reciprocal of the base. So the reciprocal of 1 over 16 is 16 over 1, And now my exponent is positive 3 over 2. Next, I'm going to simplify 16 over 1, and 16 divided by 1 is just 16. Let's change from exponential form to radical form. The inside-out method, the 3 in the top goes on the inside and 2 on the bottom goes on the outside. I need to expand so that I can simplify this root, and each one of these 16s is 2 times 2 times 2 times 2. Every time we have 2 of a kind, I can take out a number. So I have a pair of 2's, so I'm going to take out a single 2, another pair, and taking out another 2, another pair of 2's, take out another 2, another pair, another 2, another pair, another 2, and finally another pair and another 2. So let's go ahead and multiply those together because everything's out of the root, so nothing's left under the root, and I get 64. If you'd like to try one for yourself, pause the video before looking at the solution. In this problem, I need to get rid of that negative exponent, so to do that, I'm going to take the reciprocal of 1 over 625. Now that I have 625 over 1, the exponent is positive. 625 over 1 is 625. Using inside over outside, I'm going to change to root form, the 3 going in the inside and the denominator 4 on the outside. Expanding 625 cubed, I have that, and each one of those 625s is 5 times 5 times 5 times 5. I need 4 of a kind to take a number out, so every time I have 4 5's, I take a single 5 out. Everything has come out of the root, so all I have left is 5 times 5 times 5, which is 125. In this example, again, I need to get rid of that negative exponent. So I take the reciprocal of the base, and that changes the exponent to a positive 3 over 2. Next, I'm going to use power to a power multiply, taking 1 times 3 over 2, and again 1 times 3 over 2. I have 1 to the power of 3 over 2 over 25 to the power of 3 over 2. Let's use inside over outside, the 3 in the inside, 2 on the outside, 3 on the inside, 2 on the outside. 1 to the third power is equal to 1. I expanded 25 to the third power, keeping in mind that my index number is 2, I expanded, so each of those 25's is 5 times 5. I rewrote 1 as 1 times 1, again just to emphasize the 2 of a kind. So 2 of a kind, I take the number out. So for each one of these pairs, I take a number out. In the numerator, a 1, and the denominator, a few 5's. Multiplying them together, I have 1 over 125. I'm moving very rapidly on these last few examples because only the first step is different. You might pause to see if you can do this one. The first part I have to address is that negative exponent. To change that to a positive exponent, I need to take the reciprocal of 27. So I have 1 over 27 now to the power of positive 4/3. Power to a power multiply gets me to the next step. So there, 1 times 4 over 3 is 4 over 3. Changing to root form, inside, outside. 1 to the 4th power is 1, and 27 to the 4th expanded. Since I have a cube root, I need 3 of a kind, so I went ahead and wrote 1 as 1 times 1 times 1, And also each of those 27s are 3 times 3 times 3. When I have 3 of a kind, I get to take a number out. So for each 3 of a kind, I'm going to take a 3 out, another 3, another 3, and another 3. And then I have 3 ones, so I'm going to take a 1 out. Multiplying those together, I have 1 over 81.